Welcome to edupediaworld.com. You're watching the videos on surface area and volume. So in this video, we'll discuss volume of cube and cuboid. So let's say how we can find the volume and what is the use of volume, and we'll also discuss what is volume. So we'll discuss each and every concept starting from what is the definition of volume, so which is very important from the exam point of view, and we'll also discuss some of the examples related to volume, how we can find using the concepts. We will be discussing how we can solve the different types of questions. So let's get started with the first introduction now. So before discussing about the volume of cuboid or cube, we need to know what is volume actually. So volume can also be known as capacity, right? Now what is capacity? Capacity, let's say how much quantity any container or vessel can hold. Let's say we have a glass, like this, or we can say we have a cylinder like this. So we can say how much water or any liquid we can fill, right? So that's volume, that's capacity. Let's say we have a room like this. Let's say we have a cuboidal room like this. Let's say we draw a cube or cuboid. Now let's say this is a classroom. Now if we know how we can find the volume of cuboid, then we can easily know how many children or anything people can be accommodated in this classroom. So that's why that's a use and need of finding the volume. So that's actually volume. Volume can also be known as capacity of a container, or how much water or liquid or how many quantity a vessel or container can hold, right? Now first of all, we'll discuss volume of cuboid. Now what is the volume of cuboid? So let's say we have a cuboid like this, and let's say this is length or breadth. Let's say this is a length and this is the height. Now volume of cuboid can be equals to base area into height. Now always remember, volume is always equals to area into height. So you have to remember this concept very sharply. Why? Because in each and every concept we will discuss, volume will always be equals to area into height. So why area into height? So let's say we have a base area like this. So let's see this figure now. Let's say we have a base area like this, right? Let's say this is a base, or we can say this is a floor of any classroom. So let's say if this is a breadth and this is the length, right? If we want to know the capacity of this room, then if this is a base area, if we multiply this base area with height, this one height, we can know the volume. So that's why volume is always equals to area, or we can say base area into height. So you have to remember this concept very well. So now let's see what we can do for volume of cuboid. Now volume of cuboid equals to base area into height. Now over here, the base area is length into breadth, right? So let's say if this is a length, this is the breadth. So volume of cuboid can be equals to base area. So base area is length into breadth, right, into height, right? So that's why the volume of cuboid is always equals to length into breadth into height. So you have to remember this concept very carefully. Now let's discuss the volume of cube. So let's say we have a cube like this. Let's say we have a cube like this. Now in cube, we all know that all the sides are equal. So this means this will be A, this will be A, this will be A, means length, breadth and height is equal, right? We can write over here, in cube, length, breadth and height all are equal, right? So we can say that let length equals to A, breadth equals to A and height equals to A. So again, we can apply the same concept. We can say that volume of cube will be again equals to base area into height, right? So over here, base area is A times A. So this is the base area. This is the base of a cube, right? So it will be A times A, then times height. So height is also A. So this will be times A. So this means we have A times A times A. So this will be equals to A cube. So we can say now that volume of cube is equals to A cube. So we can write over here volume of cube is A cube. So this is how we can use the concept to solve various types of questions, and we'll use these concepts to solve different type of questions. So let's discuss the questions now. So let's discuss the example number 1. So example says that a wall of length 10 meter was to be built across an open ground, and height of the wall is 4 meters, right? And the thickness of the wall is 24 centimeters. Now, if this wall is to be built upon bricks whose dimensions are 24 centimeter, 12 centimeter, and 8 centimeter, so how many bricks would be required? So it's very easy and very interesting question. So let's see how we can solve this. It's saying like this. Let's say we have a wall like this, cuboidal wall. So first we need to draw a cuboid. So let's say we have a cuboid like this. We have a cuboid like this. Now, in this cuboid, the length is 10 meters and breadth is, or height is 4 meters, right? And the thickness of the wall is 24 centimeters. So you have to be very careful with the units. So let's write over here. So length is 10 meters, or we can say that 1000 centimeters. Why? Because 1 meter equals to 100 centimeters, right? Then we have height as 4 meters, so which will be equals to 400 centimeters, right? Then we have width, or we can say thickness, which is 24 centimeter, right? So we can say that now volume of wall or cuboidal wall will be length into breadth into height. So this will be equals to 1000 times 400 times 24. So this is the volume, centimeter cube, right? Now this wall has to be built with the bricks whose dimensions are 24 centimeter, 12 centimeter, and 8 centimeter. Means dimensions of one brick is 24 centimeter by 12 centimeter by 8 centimeter, right? Then this means we can find volume of one brick. So this will be equal to length into breadth into height. So this will be 24 times 12 times 8 centimeter cube, right? Now the next step is we need to find how many bricks would be required. So we can say that now number of bricks required will be equals to volume of wall upon volume of one brick, right? Now, so volume of wall is 1000 times 400 times 24 upon volume of one brick is 24 times 12 times 8, right? So now we need to do cancellation. So it will be 8 ones are 8 3. So 3 goes with 12. It will be 4. Then 4 ones are. Then it's 100. Right? Then this will come out to be 1000 times 100. Say we have over here 100 upon 27. Right? Now we need to do cancellation. So when we solve this, this will come out to be 4166.67 bricks, or we can say that 4167 bricks. Right? So this is how we can use the concepts of volume to solve various types of questions. So let's discuss the next example, which is also the last example of this video. Now, the example says that a child playing with building blocks which are of the shapes of cube has built a structure as shown in the figure. If edge of each cube is 3 centimeter, we need to find the volume of the structure built by the child. So it's very easy question and also very interesting question. So you have to watch this part of the video very carefully. Now, it's given that edge of each cube is 3 centimeter. So we can say that volume of each cube is 3 times 3 times 3 centimeter cube. Why? Because we all know that volume of cube is given by side into side into side, right? So that's why it's 3 times 3 times 3 centimeter cube. Now we need to know how many cubes are there, because this is a volume of one cube. So let's count it. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So we have 15 cubes, right? So we can say that volume of structure built by child will be equals to 15 times 3 times 3 times 3. So this will be 15 times 27, right? So when you solve this, this will come out to be 405 centimeter cube. So this is how we can use the concepts of volume of cube and cuboid to solve various different types of questions. So which questions are very important from the exam point of view, right? So thank you once again for watching this video on edupediaworld.com. Keep watching.